Okay, guys, we're going to talk about linear relations. And linear relations all have slope. So this lesson is about slope. So we know that linear functions create a line. We know that all lines are functions except for our vertical line. So we have a vertical line, and we describe the slope of a vertical line as being undefined. So let's start over here on the left and let's talk about the four states of slope. So slope simply is just the steepness of a line. So when we read a graph, just like reading a book, you always go from left to right. So you can see as we read this graph and our eyeballs run along the graph going from left to right. So I'm going left to right, and then I trace this graph, I am going in an uphill manner. So this line has a positive slope. It slopes uphill. If I go to the next graph and my eyeballs are going from left to right, and then I trace it starting at the left and moving to the going left to right, I can see that this line is going downhill in that direction. So it has a negative slope. When we have the horizontal line, which is going from left to right, I am neither going up nor down. It is staying steady and constant. So we say it has a slope of 0. And then one more time with the vertical line. As I go left to right, it is going just up and down. It's not going left or right. So this line, which is not a function, we will describe the slope as being undefined. So in your notes, make sure you just do a quick sketch. You don't have to sketch the skier, but just do, like, if I were taking notes, I would say, okay, there's my coordinate plane, my x-axis and my y-axis, and then just make yourself a line that slopes up and then write positive underneath. And then just do that for each of these. Just make sure you have a picture, a quick sketch of each of the states of slope. So let's take a look closer at a graph. And here we have this pink line. We see that as we go from left to right, it is going up. So we know we're going to have a positive slope. So this line has a positive slope. So as we go from left to right, we can pick any 2 points on our line to find the actual numerical value and actual measurement, not just saying it's positive. So slope, which we're going to use M, okay, so in the math world, M, lowercase m, represents a slope of a line. And it is the rise compared to the run, which is the vertical change compared to the horizontal change. So it is a ratio. And no matter what 2 points I choose on the line, it will always simplify to the same slope measurement because this is a line and it has a constant rate of change. So when we're identifying 2 points, as it says here, we're going to work from left to right. So if we choose this point and this point, and notice I choose points because all of these, there are points all in between, okay? There's infinite points, but we want to choose some that are on the corners of our graph paper, okay? So we're going to start from the left and go to the right. So I'm just going to pick this point and this point. And again, slope is rise, which is a vertical movement, is rise, and I choose this point and I'm working my way to here, left to right. I'm not going to go backward. And we always calculate the vertical change because that's what goes on the top of my ratio. So if M is my slope, and I'm going to have a rise number and then a run number, so I'm going to go up 1, so that's the rise, and then the run is going to the right. So since I'm going left to right, my run number will always be going to the right. So I'm going 1, 2 units. So I went up 1 and right 2, up 1 and right 2, and every time I'm going to land on the line. So this slope is 1/2. Now don't write it as a decimal, just leave it as a fraction. Now let's just say, let's erase this right here right quick. And let's say that we chose this point and this point. So we would calculate the rise first. So I go up 1, 2, and then to the right, run 1, 2, 3, 4 units. So that would be my slope is rise over run, but look how it simplifies to 1/2. So again, you can use any 2 points on a graph to find the slope. We will always simplify, and every time we will get the same value no matter what 2 points we use. So one more time, we started with a point to the left and we worked going to the right. We calculated the vertical, the up and down distance first, so up, and then the run is going to the right. And we do that second because it goes in the bottom. So let's choose any. So first of all, as we read this graph, it is going down. So we know we have a negative slope. So we can choose any 2 points on the graph. So I'm just going to choose this point and this one. So our slope is to get from this point to this point, the vertical change, which is the rise, is I went down 2, so that's where the negative part comes from, and then we're going to the right, 1, 2, 3. So our slope is -2, and then we went to the right 3. So down 2, right 3, down 2, right 3, down 2, right 3. Let's say we chose this point and this point, okay? Let's say we chose these 2 points. So we would go down 1, 2, 3, 4. So that's -4. And to the right, 1, 2, 3, 4, 5, 6. So our slope is -4/6, but it simplifies by a factor of 2, and it simplifies to the -2/3. So let's identify this, and we're also going to go ahead and learn how to do it when we don't have a graph. So here is going to be the formula. So I'm going to pick 2 points. So let's just pick any 2 points. We're going to do it algebraically, and then we're going to do it, or first, I'm sorry, we're going to do it graphically and then algebraically. So let's go ahead. Here's our 2 points. We start on the left. This point's to the left of this one. We're going to do the vertical change first. So I'll go up 1, 2. So going up is positive and going to the right is positive. 1, 2, 3. So my slope is 2/3, and I'm going to change color so we can see it on this pink. So let's identify the 2 points that I chose. So this ordered pair is -6, -2. Okay, so remember when we write a coordinate, it's x comma y like the alphabet. Slope is y/x, so they change. This second point right here is -3, 0. Now, here is what we're going to do. Let me erase this little green arrow, give us plenty of space. So this is going to be y1, and this is I'm so sorry. This is x1, and this is y1. Now, the reason these little subscripts are 1 is because this is my first ordered pair. Then we have our second order pair. So this value represents x2, and this is y sub 2. So these are the 2 points that I used to calculate the slope of 2/3 graphically, but I'm going to show you how when you don't have a graph what to do. So x1, y1, x sub 2, y sub 2. In our formula, we are going to find y2, so 0, and then it's minus, and then y1, so I'm going to use parentheses just because I have a minus and negative. And then in the denominator, we're talking about the x's because we're doing the horizontal change. So -3 minus, and then I have -6. So slope is y2 minus y1 over x2 minus x1. So you'll always be given this formula, but when you use it over and over, okay, you're gonna just naturally know it. And you can use calculators, and at some point we will bring up the calculator and show you, maybe if I remember at the end of the video, I'll show you how to do that. So I'm gonna say keep, change, change, so that's +2, and keep, change, change, that's gonna be +3. And you can see that's exactly what we got on the graph, and we should have. We could have gotten, if we chose numbers or points that are not that close to each other, we would have simplified to 2/3. Okay, so again, let's find the slope here. Let's see if, let's do the red. Okay, so again, I'm just going to use any 2 points. So I'm going to say this one and this one. We're working left to right. We're going to do the vertical change first, the changes of the y's. So 1, 2, so that went down 2, and then we went to the right 1. So our slope is -2/1. And I can just write it as just -2 is fine. Okay, let's change colors. So that was a -2. Okay, let's list the 2 pairs we used. We used 0, 5, and we used 1, 3. This is our x sub 1. This is our first y value. This is our second x and our second y. So M for slope, again, y2, 3 minus, because the formula says to subtract, y1. So we're subtracting because we're finding the distance, the difference between the point. And then we do the x's, so it's 1 minus 0. So if I do keep, change, change for that, that gives me -2, and 1 minus 0 is 1, and that can simplify just to -2. And again, it matches up. Okay, let's identify the slope graphically first. This time, let's try purple. Again, you can use any 2 points. Okay, I'll just go with this one and this one. I'm going to work from left to right. I'm going to go up 1. So that's the vertical change. Going up and to the right is 2. So we have 1/2 as our slope. The 2 points that I chose, and you can use any 2. So I'm going to list the one to the left first. This is -2, -4. And this is 0, -3. This is x sub 1 and y sub 1 and x sub 2 and y sub 2. Put it in our formula. y2, -3 minus y1, -4 over x2 minus, right from the formula. So as soon as I put that first coordinate down, I just put subtract. Then I look to see what that value is. And now I'm going to do keep, change, change, 1, keep, change, change, 2. And that confirms our slope from the graph. Okay, let's take a look at this horizontal line. So you can see that I'm going from left to right. It's neither going up nor down. Okay, I'll still just pick some points, but there's no change. So I don't have any change, and it's just steady. It's not going up or down like we said. So we're going to say this has a slope of 0. Now let's prove it graphically. So we have ordered pairs 0, 4, and we have 1, 4. X sub 1, y sub 1, x sub 2, y sub 2. Slope equals 4 minus 4 over 1 minus 0. You can have 0 in your numerator, you just can't have it in the denominator, and that will equal 0. So when you have repeating y's, 1, we know it's a function, and you can tell right then it's going to be the horizontal line with a slope of 0. Okay, what about this vertical line that we know is not a function? So on here, okay, it is it is just vertical. The change, we have no horizontal change. We just have a vertical. They're all going to be the same. So let's just pick a couple of points. So again, when you see this equation, this line, okay, we know this is the vertical line, and we don't say it has a slope of 0 or none. We call it undefined. And a lot of times we can just say UND is fine with me. So let's prove it. Let's prove algebraically. So let's just choose -4, 5 and -4, 6. So if you recall from our lesson on functions, when your x's have two different outputs, like this case, you know it's not a function. X's can't repeat like this with a different outcome. But again, let's just show it algebraically. So we have 6 minus 5, and then -4 minus -4. So that gives me 1 over 0. And when you have 0 in the denominator, we call that undefined. So if you calculate slope, and if you don't have the graph, and you don't remember that when you have repeating x's, it's undefined, but you do the math and you get 0 in the denominator, you know it's undefined slope. Okay, now we already know how to do this algebraically. So here is just the function table. I'm just going to pick the first two ordered pairs, but I am going to write them out. I just like to do this. This helps me see it better. And then I'm just going to, again, label. Once you get comfortable with this, you don't have to label. So we have y2 minus y1 over x2 minus x1. And I like to do keep, change, change. Again, you guys can use a calculator in this unit. You can use a calculator in all the units but unit 1. Okay, so we have up 3, okay, over 2. So this would look like going like up 1, 2, 3, and to the right 1, 2, up 1, 2, 3, and right 2. So that's what the line kind of would look like. Okay, again, I'm always just going to pick these first two. You can pick any two you want, and then I do suggest that you write them out of the table. You don't have to, but it just helps me. Okay, so we going to label everything while we're teaching this for the first time. We have y2 minus y1 compared to the horizontal change of 8 minus 5. I didn't really need that parenthesis, but that's okay. I want to do keep, change, change, and I get -1. 8 minus 5 is 3. So this line would slope down because it's negative. Okay, let's pick these two. We have -7, 8 over -3, 6. We have the change of the y's, 6 minus 8, and we have the change of the x's, -3 minus -7. So keep, change, change, -2 over keep, change, change. That's going to be +4. So we have and we're going to simplify, -1/2. Now, some students ask me, where does the negative go? Let me just share with you. You can have the negative in the numerator. You can have it out to the front. And you could even have it in the denominator. I don't prefer it that way. But these all mean that this is a negative value, a negative slope. We have a line that passes through -1, 12, and it passes through the point -3, 7. And we want to know how steep that line is. And so we have the vertical change of 7 minus 12, and we have the horizontal change of -3 minus -1. This is -5, and then we have keep, change, change, and this gives us -2. Now, what do you know about a negative divided by a negative? Because this fraction bar means division, we know that these cancel out and we have a positive 5/2. So this line slants upward. okay? But don't leave your answer in this form, okay? Go ahead and just cancel those out, and our slope is showing positive. So I have -7, 3, and I have -3, 3. So what do you notice about the output values? They are the same. And it's okay to have repeating y values. Um, so we know that when we have the change, and so we have 3 minus 3. So hopefully you can see that this is going to give us a slope of 0. So this was the horizontal line going through where y is 3 on the coordinate plane. Okay, let's take a look at our next example, -1, 8 and -1, 6. So what do you notice about this function table? All of our x's are the same. So this is not going to be a function. And you're going to see, so 6 minus 8 over -1 minus -1. So I get -2 over 0, and we can't have 0 in the denominator, so this is undefined. This was the vertical line passing through the -1 on the coordinate plane. So this was not a function. This equation would be x equals -1, because guess what? The x's are all -1. X is -1. Okay, now we just have these 2 points. We'll just do a few of these because I think by now you see how easy this is. You just have to be careful and make sure you insert each value in the right spot of your formula. So we have 8 minus 2 over -7 minus -4, and that equals 6. Keep, change. This gives me what? -3, and that gives me -2. So this line slopes down. 8, 5, 4, 9. Slope is the change of the y's compared to the change of the x's. So this line slopes down. It has a negative slope. The change of the y's compared to the change of the x's. Simplify, -1 over 3. This line slopes down. That slope tells me that. So the change of the y's compared to the change of the x's. And we simplify to 1 over 3. It's positive. It slopes upward. We have the change of the y's compared to the change of the x's. Keep, change, -8. Keep, change, +8. -1. This line slopes down. It has a negative slope. For those that see it, we can know that this is going to be undefined slope, but let's go ahead and prove it algebraically. -8 over 0, that is undefined. That is the the vertical line going through x is -4. So the equation would be this. Okay. And as you can see, as we are writing this, we can see that our outputs are the same, and we know that is the horizontal line, but to prove it, algebraically, we have a slope of 0. So this is the horizontal line, y equals 7. Okay, let's just do a couple. The other thing that we have to know how to do is compare slope. So when you're comparing slope, you're just going to say which is the steepest. And if one is negative and one is positive, or they're both negatives, you just disregard the negative. That just tells us the direction of the line. We just want to know which is the steepest. So here I am going to use negative 8, 8 and negative 7, 6. And we have the difference of the y's compared to the difference of the x's. And we get a slope of negative 2 over 1, so we get negative 2. So again, we're not concerned about the negative. This just tells me it goes downward. In this one, let's use negative 8, 12 and negative 6, 8. So we are going to have the difference of the y's compared to the difference of the x's. Keep, change, negative 4, keep, change. This gives us positive 2, so slope is negative 2. So guess what? These lines have the same slope. Okay, we have negative 3, negative 9, negative 1, negative 6. Slope is the change of the y's compared to the change of the x's. Again, just make sure that, see, this negative 1 and negative 6 both came from the second order pair. This negative 3 and negative 9 came from the first order. So make sure everything is in order. So on the top, we have our rise is 3, and then we have a run of 2, so 3 over 2. And then here, we are going to use negative 8, 12, and negative 6, 8. The difference of the y's compared to the difference of the x's. Keep, change, keep, change. So here we have negative 4, and then here we have 2, so we have negative 2. So this is 3 over 2, which, just looking at the numerical value, that's really like 1.5. And 1.5, and again, you disregard the negative. So 2 is steeper than 1.5. So when the higher the slope, the steeper the line. Okay, so even though this one slopes down and this one slopes up, this one's going to slope at a steeper angle. So we're going to say that function 1 has a slope that is less than function 2. So if you see this notation, this is what we'll be using. Okie doke. Let's try one more set. Change of the y's over the change of the x's. Keep, change, keep, change. Slope for function 1 is going to be 3 over 2. And then we have function 2. Keep, change, keep, change. So here we have negative 2 over 1, and we have negative 2 again. So this looks like maybe it was the same problem. But anyway, again, you ignore the negative. This is 1.5, so function 1 is less than function 2, looking at the slope. So I hope this helps you guys.